For topic 4, we're going to look at the point plotting method for graphing equations in two variables. Okay, so for our definition, we have that point plotting is a method for graphing where we find several ordered pair solutions to the equation. Next, we plot the points, so we take those ordered pair solutions and we plot them as points in the Cartesian plane and then connect with a nice smooth graph. Okay. Now I will sort of caution you on this. We can do every bit of this by hand, and I'm going to show you here in just a moment how to do this by hand. But we can also use technology to do some of the heavy lifting. However, you need to be able to justify and show me your work by hand. Okay. So in the event that I were to ask you, hey, do this by hand, I want to know that you can. Okay. You can certainly, once you know how to do it by hand, use the technology to sort of expedite the process, we'll say, but please understand the process by hand as well. Okay. So the steps. How would we do this? Well, we need to create what's called a table of values. So a table of values consists of X and Y coordinates that go together. So for this X, this is what Y has to be in order to be a solution to the equation. So we have a column of X's with the corresponding Y's that create ordered pair solutions, and we need a minimum of 3, but more like 5 to 7 is better. So we're going to kind of shoot for 5 different ordered pair solutions. Okay. Once we have figured out our table of values filled with those 5 ordered pair solutions, we want to plot the ordered pairs on the Cartesian plane. And then we want to connect the points with a nice, pretty, it doesn't have to be a line, but a nice, pretty graph. And just make sure you include arrows on the end, because you have to remember the graph is the visual representation of the entire solution set. And in most cases, we have infinitely many, well, I don't want to say most, we always have infinitely many solutions, but oftentimes our graph is going to go off forever in some direction, and we need to indicate that to our reader. Okay. So let's do this first one by hand. Okay, so we're going to do kind of like the grunt work, and then I will show you, we'll kind of verify our answer with Desmos, and then we can use Desmos to kind of expedite the process for the next 2 examples. Okay, so example 6 says graph y equals 1/3 x minus 1 by the point plotting method. Now I have given you a table of values where I started the process. I said, hey, let's let x be these values. And my reason for this is we're multiplying x by a fraction, and that fraction has a denominator of 3. Notice when you look at my list of x's, all of those x values are divisible by 3. I did that on purpose so that we would get nice, pretty y values back. So we're going to get integer values for y so that we don't have to plot little weird decimals or fractions, okay? So the good news is you have complete freedom with what values for X you choose for your table, but I would say this, choose wisely, okay? So you want to make sure you choose enough points and you choose a variety of points that will showcase the whole graph, okay? So I know in my infinite wisdom what this graph already looks like, so I've picked some pretty good values for this table, okay? So what we want to do is for each of these x values, we want to plug it into the equation and figure out what y would have to be. This is kind of like what we did in example 5. Okay, so if you go back to the previous video, what we did in example 5, we're about to do it again. We're just going to do it 5 or 6 times, so 5 different times. Okay, so when x is -6, we want to know what y is going to equal. Well, y is 1/3 times x, but we're saying x is -6. Minus 1. Well, 1/3 of 6 is 2, but notice here I'm multiplying a positive and a negative. So positive 1/3 times -6 is -2 minus 1, which is -3. All right, so that's my first ordered pair solution. Okay, so my first ordered pair solution is -6 comma -3. Okay. Now I'm going to redo the whole process. This is like a lather, rinse, repeat, 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 repeat kind of process. So now we're going to say, okay, y is equal to 1/3 x, but we're going to let x equal -3 and then minus 1. So 1/3 of 3 is just 1, but again, we're multiplying a positive and a negative. So 1/3 times -3 is -1, and -1 minus 1 is -2. Okay. And then we're going to repeat the process. Okay. So we're going to say, okay, y is equal to 1/3 times x, but this time we're going to let x equal 0. And then we're going to subtract 1. 1/3 times 0 is just 0. and then 0 minus 1 is negative 1. You should start to see a pattern here for this example because this is a linear equation, meaning the graph is going to be a line. So you're always going to have some consistent as x increases or decreases, y is going to increase or decrease, in a proportional kind of way. So you can see that our x's are increasing by 3 and our y's are increasing by 1. And that's going to be the case for the whole list. All right, but let's do it by hand. So we have y equals 1/3 times x, but we're going to let x equal positive 3. So 1/3 times 3 is just 1, and 1 minus 1 is 0. And then finally, we have y equals 1/3 times x, but we're going to let x equal 6, and then subtract 1. 1/3 of 6 is 2, and 2 minus 1 is 1. Okay? So we have filled in our table of values. That's what all of this mess right here is. This is our table of values, okay? We have our column of x coordinates, and then directly beside the x coordinate is its corresponding y coordinate. Those two match up to be an ordered pair. So for example, our first ordered pair is -6, -3. Then we have -3, -2, 0, -1, 3, 0, and 6, 1. Those are the ordered pairs we're going to graph. Okay, so let's plot them. At the origin, I want to go to the left 1, 2, 3, 4, 5, 6. Then I want to go down 1, 2, 3. I'm going to go right back to the origin, and then I'm going to plot -3, 2. So at the origin, I'm going to go to the left 1, 2, 3, and then down 1, 2. And then right back to the origin. And then I'm going to go 0, -1. So I don't go left or right, but I do go down 1. And then back to the origin. And I'm going to go 1, 2, 3 to the right and then stay there. And then finally 6, 1 back to the origin. I go to the right 1, 2, 3, 4, 5, 6, up 1. And I would try to do this as neatly as you can. I'm going to connect with a line. Whoops. And then just make sure you put your arrows because this line goes forever. Okay. And remember, the graph is a visual representation of the entire solution set. Okay. Now I'm going to go to Desmos and show you how to get Desmos to create a table of values. Okay. So remember, our equation is y equals 1/3 x minus 1. Okay. So where is Des? Oh, there's Desmos. So we're going to go to Desmos. Let's clear out the old junk. So we want to type y equals. Now to type in 1/3, you can just do 1 and then the little slash 3, and it'll automatically create a fraction. But here's the thing, you do not want your x in the denominator. You want your x either in the numerator or to the front, like to the right-hand side of the 1/3. So hit the right arrow and it'll move the cursor where it needs to go. Then type in your x and then type -1. Okay? So there's our equation. You can see right here, this is the line. And if we were to zoom out, zoom out, zoom out, zoom out, this line goes forever and ever and ever. Okay, now I'm going to zoom back in so it's something a little more realistic for us. Okay, so if you want to create a table, you type in your equation and then you always need to, this is one thing I should have mentioned, you always want it to be in the form y equals something. So sometimes you have to do a little work to your equation to get it of the form y equals other stuff. So then you hit this little settings cog up here, it's the edit list, click that, and it'll pop up these two icons. One of them will duplicate your equation and the other one will create a table. So click create table and it automatically does the work for you. Now, here's the thing. Notice they automatically have x's as -2, -1, 0, 1, and 2. But look at what you get. You get these icky values. And remember, that's because we're taking x, we're multiplying it by 1/3, and then we're subtracting 1. So if you want to always get nice, pretty integer values for y, choose values for x that are divisible by the denominator of the fraction. So if your x term has a fraction coefficient, look at the denominator and choose values that are divisible by that. So you can just type over your x list. So we want -6. -3, we'll leave 0, and then 3 and 6. and it plots those points for you so you can see right here, this duplicates that graph, okay? Now, cheater pumpkin eaters will use this exclusively. I want to know that you can graph an equation by hand. It will be a part of what I test you on in class, okay? So make sure you can create a table of values and graph an equation by hand, all right? Let's go back to the worksheet. Okay, so we've verified our results here. Let's go down here. We have, for example, 7. We have y equals x squared plus 1, okay? And notice here I have x values from -2 to 2. I'm going to do this one just kind of like really, really quick by hand so we can have our points and plot it, and then we'll verify in Desmos. So we have y equals x squared, but we're going to let x equal -2 plus 1. So y equals 4 plus 1, or 5. We have y equals -1 squared plus 1. Y equals 1 plus 1, or 2. We have y equals 0 squared plus 1. So y equals 0 plus 1. We have y equals positive 1 squared plus 1. So 1 plus 1, y equals 2. And then finally, we have y equals 2 squared plus 1. So y equals 4 plus 1. Okay, you can slow the video down. You can pause the video if you want to do that by hand, but just I was doing it quick on purpose because this video is going to be long otherwise. All right, we want to plot these points. So at the origin, I go to the left 2, and then up 1, 2, 3, 4, 5. Back to the origin, I go to the left 1, and then up 2. Back to the origin, I don't go left or right, but I do go up 1. At the origin, I go to the right 1, and then up 2. And then right back to the origin, and I go to the right 2, and then up 5, okay? Now I'm going to show you what the graph looks like. Don't do obvious points unless your graph has an obvious point in it. So sometimes it's worth checking Desmos first, but for this one, just trust the process. It's a nice, pretty curve, and it goes up and to the right and left forever, okay? So that is the graph of y equals x squared plus 1, okay? Now we're going to go right back to Desmos, and we're going to verify our results, okay? So when we go to Desmos, all right, x, all that junk out. So we had y equals x squared plus 1, so you can type in an x and then shift 6, and it'll do the superscript. And then go to the right and plus 1. So there is our graph, and that looks very much like what we had that we did by hand. Remember, you do this little like settings wheel cog that we're used to. It means edit list here. So click that and then choose the option for the table. It is by default going to have -2 to +2 for your x's. And notice that's exactly the table of values that we got by hand. Okay, so there you have it, -2, 5, -1, 2, 0, 1, 1, 2, 2, 5, and you can see the ordered pairs plotted on the graph here. Okay, so Desmos is a really cool tool to have up your sleeve. I can show you in class the TI calculator. I don't want to do that in this video or maybe separate videos. For this, we're just going to use Desmos because it's a little quicker. All right, back to the worksheet. And one more, I think. Yes. So for this last one, I'm going to do this one straight from Desmos. Okay, we have the graph of y equals the absolute value of x minus 3, and we're going to plot by point plotting. Notice here in the table, I have some really wacky values. Okay, I have -4, -2, 0, 3, and 6. They're kind of all over the place, whereas up here for both of these examples, there was kind of like a pattern to the x's that I chose. Well, down here, we've got to be really careful. When you're choosing values for x, you want to make sure that you choose values for x that truly depict the shape of your graph, okay? So sometimes it's worth doing a little bit of pre-planning, and by pre-planning, I mean take a sneak peek in Desmos to see what the shape of your graph is. So we've got y equals x minus 3, and then we have the ordered pairs that are going to start with x of -4, -2, 0, 3, and 6. So let's go to Desmos. All right, we can clear out the old stuff. All right, so we have y equals, make sure you're typing your equations in, y equals. For absolute value, I do think there is a shortcut, but for us, we're just going to go down here to this little smart keyboard or show keyboard option. And then if you look at the very first like menu of buttons, we have A, B, C, and above that we have those vertical bars with an A. Type that to start your absolute value. We wanted, I believe, X minus 3. And then type that again to end your absolute value. And then we want to go edit list and show the option for the table. Okay. Now, be really careful here. What I want you to notice, first of all, is when you use the table feature in Desmos, it is by default going to choose X to be -2, -1, 0, 1, and 2. Okay. So if we look at just the points that it plotted, like right here, I'm going to hide part of the graph. Those are the 5 ordered pairs that we've chosen. Looking at those 5 ordered pairs, it looks like we have a line, but when you see the whole graph, this is definitely not a line, okay? So you, the mathematician, when you're creating a table of values to plot by point plotting, you need to choose values that truly represent the full shape of your graph, okay? So let's do -4. I think we did -2, 0, and then I believe I had 3 and 6. All right. And now you can see these 5 points that have shown up on the graph. They do a much better job showing the full shape of the graph. They don't give you like just this little misleading snapshot of the graph. They kind of show the whole thing. Okay. So this is why we always want to choose more than 3 points. It's 5 to 7 would be much better. Okay. We could keep going too. If you wanted to add more, we could say 7. We could do 10. All right. So you can keep this table going. You could type in more than just the 5 values. The default is 5 values, -2, -1, 0, 1, and 2. But sometimes that's not going to be the best X values for us. Okay. So here we have it. Let's see. Oh, I was going to say I have my phone. I can take a picture of it. I don't have anything to write on in front of me. So we're going to go 75303. So 75303, 75303. So we have 75303. So that was our table of values. So let's plot those points. From the origin, we go back 1, 2, 3, 4, and then up 1, 2, 3, 4, 5, 6, 7. Oh, let me draw, please. Well, it's not letting me draw. Hold on, let me pause. I think I figured out my issue. I was having some serious technical difficulties. Okay, hopefully this will let me draw on it again. Okay, so we need to plot our 4 points. So from the origin, we want to go to the left 4 and then up 7. So 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7. So that point is on the graph. And then we want to go -2 and then up 1, 2, 3, 4, 5. 0, we don't go left or right, we go up 3. And then from the origin, we go to the right 3, and then we stay there. And then from the origin, we go to the right 6, and then up 1, 2, 3. And remember, the graph this time had a nice, sharp point. All right, so make your V and just don't forget the arrows on your graph. Really, truly sorry about the technical issues. I don't know why. Somehow my document just like completely froze up, okay? So that is graphing by point plotting. I had to start over with a fresh document, so I can't show you the previous graphs, but please do know that we can do this by hand for sure. We can also use technology like Desmos, but make sure you understand how to do this by hand because I could very well ask you to graph something by hand without the use of technology, okay? So understand how to do it by hand and then make sure you also understand how to use the technology to kind of save you some time when it's appropriate. All right?